Okay, question 10. We have a differential equation. So the height above ground, h meters, of a passenger on a roller coaster can be modelled by the differential equation dh over dt is equal to h cos of 0.25t over 40, where t is the time in seconds from the start of the ride. Given that the passenger is 5 meters above the ground at the start of the ride, but show that h is equal to 5e to the 0.1 sine of 0.25t for 5 max. So before we get going with that, something worth noting here is that there is no degree symbol inside of the sine function, so we are playing with radians. Okay, so what we want to do then is solve this differential equation. So let's do that. So dh by dt is h cos of 0.25t all over 40. Now on the right we have both a h and a t, so we're going to need to split the derivative, get the h's on the right and the t's, sorry, the h is on the left and the t's on the right. So if we divide through by h and multiply through by dt, we get dh over h is equal to, now I'm going to take out this 40th as well, so we got 1/40 of cos 0.25 dt. At this point we can integrate both sides, so dh over h integrates to log h. Now on the right we get 1/40 of cos integrates to sine, and by the chain rule we get 1 over 0.25. So we get sine 0.25t over 0.25, and then don't forget the constant c. So we got log h is equal to, now 1/40 times 1 over 0.25 is going to give us 1/10. 1/10 is 0.1. So we got 0.1 sine of 0.25t add c. So it's starting to look how we want it to look. Now to get rid of that log, we're going to raise both sides as a power of e. So we get h is equal to e to the 0.1 sine of 0.25t add c. Now we can say that right hand side is e to the 0.1 sine 0.25t times e to the c, just using the rules of indices. So if we say let a equal e to the power of c, h is equal to a e to the 0.1 sine 0.25 t. And now we use our initial conditions. So we know at the start of the ride, so when t is equal to 0, the height of the passenger was 5. So h is 5. So that's going to give us 5 is equal to a e to the power of 0. Therefore, a is equal to 5. And finally, h does equal 5 e to the 0.1 sine 0.25 t, as we wanted it to. Okay, then part B for 1 mark wants us to state the maximum height of the passenger above the ground. So we now know that h is this lovely thing. So what we need to think of is what is the max value of the sine term. So the max of sine 0.25 t is 1. So that is going to lead us to the maximum height. So that's going to be 5 e to the 0.1, which, if we go to 3 sig figs, is 5.53 meters. Cool. Okay, then for part C, we are told the passenger reaches the maximum height for the second time t seconds after the start of the ride. We want to find the value of t. So, again, remember now, we are in radians, so we know the maximum height occurs when the sine term is equal to 1. So let's sketch sine. So sine looks like that. So this would be the first time that we reach the maximum height. So that would be at pi over 2. So that would mean we would set 0.25 t equal to pi over 2. We want the second time though, so that's going to be here. So that's going to be 2 pi later. So that's going to be 5 pi over 2. So we need sine of 0.25 t to be identical to sine of 5 pi over 2. So that means 0.25 t is equal to 5 pi over 2. Now if we multiply both sides by 4, we get t is equal to 20 pi over 2, which is 10 pi, which to 3 significant figures, it would give us 31.4 seconds. Cool.